All right, so Semex2 study guide, problem number 9. And you're asked to solve, and you've got the square root of 5x minus 1 is equal to the square root of 4x plus 9. All right, so in order to eliminate the square root symbol, just square both sides. And what you're left with is 5x minus 1 equals 4x plus 9. And you can subtract 4x from each side and add 1 to each side. So we get x is equal to 10. And then problem number 10. You're solving and identifying any extraneous solutions. We've got x is equal to square root of 4x plus 12. So again, we're going to get rid of this square root symbol by squaring both sides. We get x squared is equal to 4x plus 12. And then we're going to move everything to one side of the equation. And I want to keep this x squared positive, so I'm going to subtract 4x from each side and subtract 12. So what we get on the left-hand side here is x squared minus 4x minus 12 is equal to 0. So we're going to factor this trinomial, and it factors to x minus 3 times that's incorrect. 6 and 2, it looks like x minus 6 and x plus 2 equals 0. Negative 6 plus 2 is negative 4. Negative 6 times 2 is negative 12. So then we set each factor equal to 0. So I'm going up here. I'm going to take x minus 6 equals 0 and x plus 2 equals 0. I'm going to add 6 to each side. X equals 6. Subtract 2 from each side. And x equals negative 2. You have to check these solutions now in the original equation. The original equation was right here. It was x equals the square root of 4x plus 12. So if we check this 6, does 6 equal the square root of 4 times 6 plus 12? Does 6 equal the square root of 36? And it does. So this solution works. That is a good solution. If you look at this next solution and plug it into this original equation, it would be negative 2 equals the square root of 4 times negative 2 plus 12. Well, a square root can never be equal to a negative. So this negative 2 is extraneous. X equals negative 2 is extraneous. So one good solution, one extraneous solution. All right, problem number 11. You're asked to simplify the rational expression, state any excluded values, and we got 4x minus 8 over 4x plus 20. So first thing is to factor the top and the bottom. So I could factor a 4 out of the top. Now I'd have 4 times x minus 2. I can factor a 4 out of the bottom, and I would have 4 times x plus 5. So right now, I would identify any excluded values, okay? X cannot be equal to negative 5 right here, because that would create a 0 in the denominator. We can't have that, all right? So then, with what's left, I can cancel these 4's, and in simplest form, we get x minus 2 over x plus 5. Well, we're simplifying again. We have negative 14x to the third over x to the third minus 5x to the fourth. There's nothing that can be factored out of the top, so it stays the same. Out of the denominator, we can factor out an x to the third. And when we divide x to the third back into the denominator, we would get 1 minus 5x squared. All right, so these x to the thirds cancel. We're left with negative 14 over 1 minus 5x squared. If we set each of these factors equal to 0, if we say that x to the third is equal to 0 and 1 minus 5x squared is equal to 0, that will give us our exclusions, okay? So x cannot be equal to 0. And then if we subtract 1 from each side, negative 5x squared equals negative 1. And then divide each side by negative 5. X squared equals 1/5. And then if we square each side, or find the square root of each side, then x is equal to positive or negative square root of 1/5. So that would be your other exclusion, all right? X cannot be equal to positive or negative square root of 1/5. That would create a 0 in this factor. And x just being equal to 0 would create a 0 in this factor. And if you multiplied those two factors, anything times 0 is equal to 0.